my students of class 11. Today we'll be continuing with our class on this variable covalency. So first, you know what is covalency? Covalency is the number of valence electrons which an atom shares with the electrons of other atoms of the elements to form covalent bond. So that you already know it. But today's topic for discussion is variable covalency. Now there are certain elements which show more than one oxidation state. That means sometimes in some compound they share only 2 electrons, in some they share 3. So the reason behind that we are going to discuss today. So for this you have to remember generally the number of valence electrons are responsible, unpaired electrons are responsible for what? Covalency. That means now generally in atoms the number of unpaired electrons in s orbital and p orbital are responsible for its covalency. Now you know in certain compounds like oxygen, its atomic number is 8. So it has electron configuration 1s2, 2s2, 2p, 4. Oxygen lies in which group? Group 16. Below that you have sulfur. Sulfur, again here's electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3s2, 3p4. Now, whenever there is covalent bond formation, what will happen? There has to be what? Exchange of energy. Yes or no? Now, see, oxygen, whenever I'm going to write its electronic configuration for the purpose of bond formation. Only the valence electrons are taken. Here with principal quantum number 2 are its valence electrons. So oxygen will be having these electrons 1, 2, 3 and 4. So this is 2s orbital and these 3 are 2p orbital. Similarly here on the valence electrons, valence cells are taken. 3 is the outermost quantum number, largest quantum number. Therefore, you have sulfur equals to 1, 2, 3, 4. Now, in your more classes, you have studied about like if an element lies in the same group, like oxygen and sulfur, then they will be showing same valence. That is true up to that level itself, but as you come to class 11, since we are learning about variable covalency, we will know the reason why some of them show, even if they lie in the same this group, they will be showing different oxidation number. That means different covalency. Okay? So here in oxygen, what you have? You have these orbitals. Can you see how many unpaired electrons are there? This is one unpaired electron and this is another unpaired electron. Therefore, it can show covalency of 2. Similarly, sulfur in its ground state. Now we are discussing about ground state. This term is very important. Ground state, excited state. So in ground state, what happens is like the energy of this particular molecule is low. Now, whenever there is bond formation, what will happen? The atoms of each other, they will collide, then they will get higher energy. That means their energy will be more once they collide among themselves. That is known as what? Excited state. In the ground state, the number of electrons that are unpaired in sulfur is 2 itself. It's what? 2. Therefore, its covalency will be 2 in ground state. Please remember, GS means ground state. But once this sulfur gains more energy, what will happen? Now it goes in excited state, means it gains more energy. Now once it gains more energy, what will happen is this part is very important for hybridization and as well as covalency. Now these two electrons are here. Now these two electrons were here. This was the electronic configuration, the ground state exactly the same. Now sulfur lies below oxygen. Yes or no? That means group, this is period 1, this is oxygen till period 2, you don't have vacant orbital. From third period itself, from third period onwards, what will happen? They will be having what? Vacant d orbital, and this is very important. This part, 5 orbitals you can see, these are vacant d orbital. Oxygen, it doesn't have a vacant d orbital. Why? Because it lies in period, second period. Third period onwards, you will be having what? Vacant d orbital. Therefore, now once this sulfur gets more energy after colliding, then what will happen? Its electrons now can be shifted to the higher energy level because it has gained energy. Now this period of electron can be shifted to this orbital, vacant d orbital, in the first excited state. So here can you see now, how many unpaired electrons are there? 1, 2, 3, 4. Here it has 4 unpaired electrons, therefore now it can show covalency of what? Covalency of 4. Similarly, you can see that here vacant spaces are present, and here again one more unpaired, here again you have paired up electron. Now what will happen? If it gains more energy, then it will go to next higher excited state, in which this electron also now can be shifted to this d orbital. So once this electron is also shifted to d orbital, how many unpaired electrons are present over here? You can count it. Now here 6 unpaired electrons are present, and as a result it will show covalency of what? 6. So our main point of discussion is what? Oxygen shows only the covalency of 2. Why? Because it doesn't have vacant d orbital. Whereas sulfur, it shows covalency of 2, 4 as well as 6. So all this depends upon what? It depends upon the number of unpaired electrons in the valence shell, and you have to see whether they contain vacant d orbital or not. And I told you a way to remember. Third period onwards, they will be having vacant d orbital. Similarly, you can try for nitrogen and phosphorus. Nitrogen, it shows covalency of 3, whereas phosphorus will show covalency of 3 as well as 5. So that will be your part of doing this covalency. Okay? Now let's discuss about bond length. And bond length, you know, it's very easy definition of it. What is bond length? It is the internuclear distance between the two combining atoms. Okay? So bond length is defined as the equilibrium distance between the centers of the nuclei of the two bonded atoms in the molecule. This definition is given in your book. You can refer from there. Now, here are certain definitions that you need to learn, know it. Okay? So you better take help from the book. The part where I have to explain, I'll be doing that. So the amount of energy. Now we are discussing about bond dissociation energy. Hope this covalency is clear. Variable covalency. Try for nitrogen and phosphorus. Definition of bond length. It is the equilibrium distance between the nuclei of the two combining atoms. So that is done. The second one is bond dissociation energy. It is dissociation energy. Bond dissociation energy. So bond dissociation energy Okay, here also you have to remember this definition, particularly one mole part. Okay, Avogadro's number. So let me do this definition. The amount of energy required to break 1 mole of bond. Please don't forget this 1 mole of bond. That is Avogadro's number of bonds, so as to get isolated gaseous atom. So what is important here? The energy required to break 1 mole of bond, so that you are going to get what? Isolated gaseous atom. Isolated gaseous atom. This much energy is known as what? Bond dissociation energy, and it is denoted by D. Now there is a difference between bond dissociation energy and bond energy or bond enthalpy. So this is the energy required to break 1 mole. That is Avogadro's number, and you are going to get them in isolated gaseous state. So that part is done. Now what is bond energy or bond enthalpy? Now this is the average, please remember. It's defined as the average value of bond dissociation energy. It is the average value of bond dissociation energy of the same type of bonds present in the molecule. So bond energy or bond enthalpy is what? It is average energy of the bond dissociation energy. For example, now let's take example for CS3. Now to dissociate all the bonds of CS3, the amount of energy that is required is how much? 1661 kilojoule. Okay, this much of energy is required to break all the 4 bonds of CS4. What is the amount of energy required? 1661 kilojoule. Now, what is bond enthalpy then? Bond enthalpy is the average. How many bonds are there? There are 4 bonds. Therefore, energy required, it is the average energy required. Okay, average energy required will be what? 1661 divided by how many bonds were there? 4. So when you divide this particular number with 4, you get a certain value over here. That value will be known as what? It will be known as bond enthalpy or bond energy. Hope this is clear now. And this particular value is here it is 415.25 kilojoule per mole. Kilojoule per mole. So this energy is known as what? Bond energy or bond enthalpy. Now let's discuss about factors affecting bond enthalpy. Factors affecting bond enthalpy. Number 1. So the first point that we have is bond length. So let me write first bond length. So here, sort of the bond length, more will be the what? Bond enthalpy. Okay, because it will require more energy. If sort of the bond means what? They are very highly attracted to each other. So to separate them or to break the bond, you need more energy, obviously. So its bond enthalpy will be more. The second point that we have is the size of bonded atoms. So smaller the size, greater will be the energy bond enthalpy or bond energy. So second point that we have is the size of bonded atoms. Size of bonded atoms. Now here, smaller the size, more will be the bond enthalpy. Please remember that. Number 3 is electronegativity. Number 3 point is what? Electronegativity. So higher the differences between, higher is the difference in electronegativity between the combining atoms, then its bond dissociation energy. In fact, bond enthalpy will be higher. So greater the electronegativity difference, greater will be the value of bond enthalpy. So next point that we have is bond multiplicity. Bond multiplicity, what does it mean? It means that whether single bond, double bond or triple bond. So if we have double bond and triple bond, that is known as what? Multiple bonding. And if you have multiple bonding, that is double bond and triple bond, obviously the bonding there will be stronger and bond enthalpy will also be higher. Okay? Now one point that you have to remember is the fifth point, that is number of lone pair. Number of lone pair. So whenever there is lone pair, okay, lone pair, then it's going to affect the bond energy. So higher the number of lone pairs, what will happen? Bond enthalpy or bond energy will be less. Okay? Here, one more point that you have is hybridization. That hybridization, it depends upon p character. Okay? It depends upon what? P character. So hybridization number 6 point is what? Hybridization. Higher the p character, bond enthalpy increases with increase in p character. So you have bond enthalpy increases with p character. That means you have learned about sp2, sp3. In sp3, there is highest percentage of this p character. So sp2, then comes sp, then comes p, then comes s, etc. Okay, this trend has to be followed. Now, let's discuss about bond order. So these were the 6 factors which affected the bond enthalpy. Okay, you have to remember them, and you have to remember the trend, whether it increases or decreases. Now, the next topic is bond order. So bond order is very simple. So if I give you an example, suppose you have fluorine and chlorine, you have oxygen molecule, you have say nitrogen molecule. So here the bond order is 1, here the bond order is 2, and here the bond order is 3. So bond order in a way tells us whether single bond, double bond or triple bond is present between the combining atom. Okay? So bond order is given by the number of bonds between the 2 atoms in a molecule. You have to remember this, and you have to remember isoelectronic molecules. Now they will be having the same bond order. For example, you have fluorine. Fluorine has 9 into 2, 18 electrons. 18 electrons. Oxygen, you know it has 16 electrons. And if I write 2 minus over here now, that means 16 plus 2 minus will be what? 18 electrons. Now these are what? Isoelectron. Why iso means same. Same number of electrons are present in F2 and O2, 2 minus. Therefore, now their bond order will be same, and the bond order of N2 you already know it is 1. Therefore, both of them will be having the bond order as 1. Let's remember this. And one more point, two more points in fact that you have to remember from this, and this is very important. Greater the bond order, greater is the stability of the bond. You know it? Why? Bond order here 99 is 3, that means triple bond is present, strong interaction, and its stability is very high. Okay? And to break them, you need more large amount of energy, therefore its bond enthalpy will also be higher. And the next point that we have is greater the bond order, shorter the bond length. So if you have greater bond order, the bond length would be shortened. Now if single bond, double bond and triple bond, so among these three, this is the shortest. The bond length in nitrogen is the shortest, then comes oxygen, then comes chlorine. So with this we end the discussion for today's class. We'll be seeing you in the next video. Till then, take care. Bye bye.